Hi everyone, before we get started, I just wanted to review some geometry concepts that are going to pop up in the lesson. If two sides of a triangle are equal, they're congruent, and the angles opposite them are also equal. And you can see in the diagram I'm demonstrating that theorem. Also, another topic that shows up, angles that are a linear pair, in other words, angles that are next to each other and form a line, they're always going to sum to 180 degrees. Now, we're also going to be using the inverse trig function. When you use inverse sine, you're asking what angle has a sine of that value. So, for example, if I'm saying, what's the inverse sine of the number 2? I'm going to get an error because that's asking me for the sine curve, where is my output value going to be 2? And if you look at the graph of the sine curve here, you can see that it doesn't go higher than 1 or lower than -1. So in this case, the inverse sine does not exist, and there would be no solution. In this lesson, we're talking about the sine rule, including the ambiguous case. So first of all, I have the formula for the sine rule written here, and I just want to remind you that always use your formula booklet, always have that handy as a reference. Let's take a look at that. If you look at your formula booklet under topic 3, you're going to find the sine rule is there. All right, so, and just keep in mind when you're using the sine rule, we don't have necessarily a right triangle. It doesn't matter. It could be any triangle. It doesn't have to be a right triangle. So we have an example here, and it says to find the measure of BC. I'm trying to find this. And BC is across from angle A, so I'm just going to call this lowercase a. I just find it easier to work when I'm just using one letter as my variable instead of trying to use BC. So we know that we're going to need in our formula A over sine A. And then notice it says it is usual to only use 2 of these fractions. We're just going to use the ones that we need. We also have in this triangle angle B and side B, so we're going to use that in our ratio. All right, we'll just fill that in. So we don't know A. We know that the angle A is 38 degrees. Across from angle B is side B, so that's 12. And we have the sine of angle B, and B is 44 degrees. Right? In order to solve for A, we're going to cross multiply. So we're going to have A sine of 44 degrees equals 12 sine of 38 degrees. And to solve for A, we're going to divide both sides by the sine of 44 degrees. So A is equal to 12 sine 38 degrees, all divided by the sine of 44 degrees. Now, you could have done all that hard work and make a mistake when you put it in the calculator. So we're going to put it in the calculator together. Just be really careful. Use parentheses. We're going to make sure we're in degree mode. At the top of my calculator, you can see I'm in degree mode. If you're not sure, you're going to press the mode button highlighted in red. You're going to scroll down, and you're going to make sure that degree is highlighted. And then you can do second mode to get out of there. Okay, and when we do that, we see we get 10.6 centimeters. So A, which equals BC, which is what we're trying to solve for, is approximately 10.6 centimeters. All right, moving on to example 2, we're being asked to find AC. Now I'm going to label all my sides. Across from angle A is lowercase a, across from angle B is lowercase b, and across from angle C is lowercase c. All right, and we're trying to find side AC, so we're trying to find letter B. So I know that I'm going to use B over sine B. So I have this side C, so I know I'm going to have to use C over sine C. and I'll just fill that in. All right, now we're going to cross multiply. We're going to divide both sides by the sine of 45. We're going to put that in the calculator. All right, moving on to the next page. So we've seen combinations of sides and angles associated with the criteria for congruent triangles. All right, so let's just go back and look at these two examples and identify what we had, just as a little geometry reminder here. So we were given an angle, and we were given an angle, and we were given a side. So we have angle, angle, side. All right, that's one scenario we saw for number one. If we take a look at number two, let's see, we had an angle here, we were given an angle here, we were given an angle here, and we had a side. So in this case, you could say we had angle, side, angle. We also have angle, angle, side. All right, so other scenarios that you could see are side, angle, side, 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 hypotenuse, leg. Hopefully these ring a bell from your geometry days. Now, there's one scenario where we can't just go about just assuming that there's one answer. So we saw that side, side, angle did not work to prove triangles were congruent. Now, we could also write that as angle, side, side. That we don't want to see on the paper. That's not very nice. So instead of that, we call it the Donkey Theorem. And if you remember from geometry, we couldn't prove triangles were congruent when we had the donkey, when we had a donkey scenario, angle, side, side, or we usually write it on our paper to be nice. Instead of writing, angle, side, side, that's not very nice. We write side, side, angle. Right, so this is what we call the ambiguous case. When we have the Donkey Theorem, right, and we want to use law of sines, we have to take into consideration that there's a possibility of either no solution, one solution, or two solutions, right? So again, we could have no solution, we could have two solutions, or we could have one solution. So the first thing you have to recognize whenever you're going to use, the law of sines, you just have to see, do we have the donkey scenario? Now, how do we know? By looking at it. Well, first of all, you would have an angle and you would have the side opposite that angle. So in this case, we've got angle B and we have side B. All right, if we have that and one other side, we know we have donkey. So if we have that, we know there's a possibility that it could be no solution, two solutions, or one solution. Now, I have come up with a way to make this really easy, and there's a process, though, that you have to follow. And the first part of the process says that if you have angle, side, side, what you have to do is you're going to draw the triangle, and don't worry about it being to scale. We're always going to put the angle we have in this bottom left corner. Always put the angle you have in the bottom left corner. Right? And then the side opposite angle B, of course, is here, and that's equal to 5. And we want to put the other side we want to put that right here. Okay? So you're going to have angle, side, side. Right, so we're going to put the other side that we have right here. So this is going to be side C, which means this is angle C, and that would make this angle A. So that setup is really important. If you fell asleep when I was talking just now, you want to pause the video, rewind, and listen to that again. All right, so now we're set up. So first of all, we're going to go ahead and set up the law of sines. And of course, we're using side C, that means we need angle C, and side B, which means we need angle B. So, and now we're going to fill it in. All right, we're going to solve for the sine of C. So we're going to cross multiply. We're going to divide both sides by 5. So we're going to get the sine of C equals 12 sine 78 degrees divided by 5. And we have to undo sine, so we have to take the inverse sine of both sides. We're going to take the inverse sine of both sides. Whenever you're trying to find an angle, you're going to take the inverse of that. C is equal to the inverse sine of 12 sine 78 degrees divided by 5. So let's do that in the calculator. I'm going to take the inverse sine of my answer, and we can use that little answer button right here. It's next to the enter. If you do second negative symbol, it'll just copy in automatically what was in your previous step. And we get an error. Okay, if we get an error, we know in the calculator that there's no solution. And we get an error because if you think about the sine function goes up and down between the value of -1 and 1 and 2. All right, we get this value of 2. That's outside of the original sine function. Now you don't have to remember that. All you have to remember is if you get an error in your calculator when we do this, that means there's no solution for this problem. So this is no solution. Okay, so we're going to do this whole process again. All right, first of all, we're going to look at the problem. We have an angle, and we have that side across from that angle, and we have another side. That means we have side-side angle. We have a donkey situation. So we're going to draw the triangle just the way I told you to draw it. The angle we're given is always going to be put in this bottom left corner. So the angle we're given is A. A is 26 degrees. Across from angle A is side A. And the other side we're going to put right here, always, to set ourselves up for figuring this out. All right. If this is side B, then this has to be angle B. And then that means this must be angle C. So now we're going to set it up. All right, so A is 21. Sine is 26. B is 5 over sine B. Okay, we're going to cross multiply. We're going to divide both sides by 21. So we're going to get sine B is equal to 5 sine 26 over 21. Now, to undo sine, we have to take the inverse sine of both sides. We're going to take the inverse sine of both sides. Let's do that in our calculator. Hopefully we won't get an error this time. All right, we're going to take the inverse sine of our answer. And we're going to get a value this time. So this time we get about 6 degrees. So the value of B is approximately 6 degrees. Now, we know that we have this angle side. We have a donkey situation. So we know that B can be 6 degrees. But the other thing is we could have another triangle that could be formed. And what you would try to do here is you would draw the other triangle. All right, and we would assume that that side, right, this could be A this time. This could be side A equals 21. All right, if that side is A is 21, that would mean this angle is also 6 degrees. Okay, angles opposite congruent sides are congruent. This is a geometry theorem. Now, here's the part where we test to see if we have another possible solution. We're going to look at that angle right there. Well, we have a linear pair here. This angle plus this angle makes a line. So 180 minus 6, that means that that angle there is going to be 174 degrees. And the question you have to ask, is it possible to have another triangle if this is 174 and this is 26? Could this still be a triangle? Like this triangle here, could this make a possible second triangle? Well, 174 plus 26 already puts us over 180. So we know we definitely only have one possible solution. So this case is one solution. So let's write that down. This is going to be one solution, all right? And that's because 174 plus 26 is greater than 180. Right? So we know that we definitely only have one solution, and our solution is B equals approximately 6 degrees. All right, let's take a look at another one. Your head's probably spinning. It's okay. All right, you're going to get the hang of it, but you want to look at all three scenarios before you try it on your own. All right, again, we have an angle, and we have the side opposite that angle, and we have another side, so we know we have a donkey. We're going to draw the triangle. The angle we have is always going in the bottom left corner. We have angle A is 29 degrees, and across from angle A is side A, that's 6, and we're always going to put our other side on the left here, B equals 10. Right? Across from side B is angle B, and that leaves C up here. So we're going to write out our law of sines, our sine rule. Now, by the way, just like we could write A over sine A equals B over sine B, I could put the sine on top if I want to. I just want to show you that you're allowed to do that. So I'm going to write it this way this time. Sine of A over A equals the sine of B over B. Certainly allowed to do that as well. Right, so we're going to write out the sine of 29 degrees over 6 equals the sine of B over 10. We're going to cross multiply. I'm going to divide both sides by 6. To undo sine, we have to take the inverse sine of both sides. On the left, that's going to leave me with the inverse sine of 10 sine 29 degrees over 6 is going to give me the value for B. Now remember, if we put this in our calculator, we get an error, we know we have no solution. If we get a solution, then we have to test to see if there's more than one solution. So let's first put it in our calculator. I'm going to take the inverse sine of that answer. And we get approximately 54 degrees. All right, so we know that B, which is approximately 54 degrees. All right, so we would put 54 degrees here. And now we're going to test to see, is it possible to have another triangle? So we have our first triangle, right? That is this triangle. We know that this is going to work. But now we want to see, is it possible that this triangle works? Okay, if I were to swing this side over, right, so then this would be now A equals 6. This is going to be 54 degrees. We want to know what angle would be there. Well, that angle would be 180 minus 54 degrees. 180 minus 54 degrees, because these two angles make a linear pair. They form a line. 180 minus 54 is 126 degrees. So my question now is the blue triangle a possibility? As long as 126 plus 29 is less than 180, we know the blue triangle is a possibility. And if we say 126 degrees plus 29, well, that gives us 155 degrees. And that's below 180, right? 155 is less than 180 degrees. So we know that a second solution is possible. So the other possible solution is that B, I'm going to say that B could be approximately 126 degrees. Right, so second solution is possible. We have the two scenarios. All right, let's take a look at one more, and this one I would like you to try it on your own and then come back when you're ready. Okay, so we have triangle ABC, we have angle B, and we have the side across from that angle, and we have another side, so we know we have a donkey situation. So we are going to draw the triangle first. You're always going to put the angle we have in the bottom left corner. So B is 34 degrees. Across from angle B is side B. And the other side that we have is always going to go on the left here. If that's side C, this is angle C, and then this must be angle A. All right, now we're going to write out the law of sines. We're going to fill it in, use our substitution. Cross multiply. Okay, divide by 15. We get sine C equals 20, sine 34 over 15. To undo sine, we have to take the inverse sine of both sides. So on the left, we have C, and on the right, we have the inverse sine of 20 sine 34 over 15. Do that in our calculator. And do the inverse sine of that answer. And I get approximately 48 degrees. All right, so I know that C definitely is going to be a possibility at one solution. We get 48 degrees. All right, so we're going to write 48 degrees. Now we're going to test out to see if it's possible to have another triangle. This would be 15. This would be 48. And again, just like the last problem, we are sure that this triangle exists. And we're testing to see now, could this triangle be a possibility? So if this is 48 degrees and this angle here is a linear pair with 48 degrees, 180 minus 48 degrees, that gives me a value of 132 degrees. So is 132 plus 34 less than 180? Well, 132 degrees plus 34 degrees, that gives me 166. Well, 166 is less than 180. So we know that blue triangle is also a possibility. So we know that we have a second possible solution. All right, and the second possible solution is that C is approximately 132 degrees. All right, there was a lot in this video. These just take a lot of practice. All right, make sure you draw the triangle the way I'm recommending. Won't have any trouble. If you get an error in your calculator, you know there's no solution. Otherwise, you're going to get one solution, and then you just have to test to see if there's a second solution. Okay, thanks for watching. Have a great day.